Okay. Okay. Let me just finish the. Perfect. Hello, everyone. Hi, Professor Tharun. Can you hear me? You are on mute. Okay. Perfect. Let me start sharing my screen and then we go from there. Okay. All right. Great. Great. Wonderful to have all of you in this session. Hi, Professor Tharun. Are you able to hear me? Just give me a moment. Yeah. I can't hear you. I think you are on mute, Tharun.
Yeah,
Yes. Perfect.
I hope
Perfect.
I'm on. Yeah. So, yeah, good evening, all of the participants for this masterclass. And I would like to thank all of you for coming to and trying to learn about the course, basically the PG certificate program in applied data science and AI, which is organized by both CloudxLab and IIT Roorkee. Yeah. So, can we move to the next slide?
Yeah. So I'll introduce you with Tarun. So basically, this is a session where we talk about data science, machine learning, AI, and then the flow of the session is that we will have the introduction of speakers, then we'll talk about IIT Roorkee, then CloudxLab, then we'll talk about the data science, machine learning, and AI, and then we'll talk about the data science and AI applications, and then we'll learn basics about how the ChatGPT works, and then we also talk about the typical workflow of building an ML project. This session is going to be of 2 hours, and they're going to be 10 minutes break. Except for the speakers, everyone is going to be on mute. Please use Q&A or chat to ask questions. If you are on YouTube, ask the questions in comments. My team will pick those questions, paste it in here. And all right, meet Professor Tharun. Professor Tharun has done his graduation and master's from IIT, both as well as PhD from IIT Kanpur, and he has been very I would say involved with the machine learning from quite some time. Over to you, Tarun. Would you like to add something to this? Yeah.
Yes, thank you, Sandeep, for the introduction. Um, as Sandeep has introduced, like I am currently working as assistant professor in the Department of Electronics and Communication Engineering at IIT Roorkee. I'm also a joint faculty at the Center for Indian Knowledge Systems at IIT Roorkee. My primary area of research or my work is primarily oriented in the direction of machine learning and especially signal processing for machine learning. And the applications are human-computer interaction, brain-computer interfaces, and computer vision. Yeah, prior to my journey at IIT Roorkee, I have been in the industry for 1 year with Brainwave Science company. So Yeah, so I belong to the institution at which I'm currently contributing to. So this is IIT Roorkee, Indian Institute of Technology Roorkee. So this is one of the very oldest technical institution in Asia. So recently we celebrated 175 years for IIT Roorkee's uh, being for more than 175 years and establishing itself from 1847. So IIT Roorkee is one of the premier institutes in India, one of the typical IITs, Indian Institute of Technologies. So it ranks. So recently we have got a NIRF ranking. So IIT Roorkee ranks in the top 10 institutions. So basically it ranks around exactly eighth position in the overall category. And in the innovation category, IIT Roorkee is also ranked around sixth position this time. So basically, it's one of the top IITs at which anybody would like to want to study in the domain of engineering or technical education. So we offer bachelor's degrees in 11 disciplines and postgraduate degrees in around 55 disciplines. And I also want to share that we have currently 23 departments at IIT Roorkee, so which include all engineering as well as all other allied subjects. And we have 9 centers of excellence also at IIT Roorkee currently, so which are oriented in specialized domains or specialized area of expertise of the faculties at IIT Roorkee. And the need of the industry, of course, need of the nation and the need of the industry. So we have 9 centers of excellence. And I want to tell this specifically because we have also a school of AI at IIT Roorkee, which focuses on data science and AI research and oriented applications. And all these are with well-equipped, lab for infrastructure and central library. And to conclude about IIT Roorkee, here we have students from more than 50 countries who are joining IIT Roorkee for full-time intern or short-term courses. Yeah, Sandeep, next slide. Yeah, so as I was mentioning that we have among the IITs as per QS rankings 2021. So the citations for faculty reflects the number of times your research work is cited by the peer researchers in your area, in your research area. So among the IITs, as per citations for faculty, IIT Roorkee stands first. And so this is 2020 ranking. Yeah. So as I mentioned before, the NIRF ranking this year also we have. And so among Asian institutions, it is 83rd. And so we have also improved ourselves in the QS rankings worldwide. So from the last year, you can move to the next slide. Yes,
Oh,
over to Sandeep.
okay. Okay. Perfect. Perfect. So about myself, I'm one of the founders of CloudxLab. So I graduated from IIT Roorkee in 2002 and have worked on large-scale computing and software engineering at Amazon, InMobi, DE Shaw. I also founded Tibet's Global, and then I founded a company prior to this. And so basically, the my actual passion is to do the engineering, machine learning, and I also enjoy explaining technologies to people, my friends, and the family members. So that's how I realized that the CloudxLab would be a great a journey for me, and it has been a successful journey. So. And currently, I'm working with multiple projects, specifically in North America. Uh, the recent one I'm working on with a company, one of the projects that is going on at CloudxLab is with McKesson, and it's basically cancer research, applying AI into cancer research. So that project is has been pretty successful. Partly, the first milestone has been successful, and there are more projects on the way, and that's how the at CloudxLab we are essentially applying AI in the industry. Right. So the CloudxLab started with a very clear vision that to upskill engineers and IT professionals. And one of the good things that we had done was creating this playground whereby the problem statement is on the left-hand side and the exercise is on the right-hand side. When you submit, when you submit the exercise, it gives you a feedback that you have done a good job. And from the console, from the command line, you can also access all kinds of tools. You can directly interact with all the tools. So it's not only the playground. Of course, the playground is very, very useful. For every topic in the course, we have such kind of exercises where you have to do the hands-on. And it gives you a real experience of working with real environment. The environment that you see on the right hand side, it's not our environment. It's something called a notebook, Jupyter notebook, just like Google Colab. This one basically is based on that, so you can run any Python code and so on. The only additional advantage is that our environment, our CloudxLab environment can probe it and check whether you have done the work or not. And accordingly, it keeps on giving you hints and other things. And on top of it, we have access to all kinds of tools. Very important part is we do not differentiate between one course and another. The lab is common for all. So those who are want to work with machine learning on Spark or big data or data engineering, they're more than welcome to do it. So and many people do that. They basically use the machine learning and data engineering together, and that's how they learn. I will talk towards the end, where do the data engineering and machine learning overlap, and how does it overlap, and how does the AI overlap. I'll talk about a couple of real projects towards the end of the webinar. And there you will find it very handy that these tools being available to you are really, really helpful in solving real projects. CloudX Lab was designed with a simple purpose that it should be real world experience. It should be a seamless experience, and the data sets have to be central, and it can be accessed from any website. And we have been successfully able to do that. You can use CloudX Lab from your phone, the laptop, and you can also use it from anywhere. And it's not restricted to a particular laptop, or you need to install a software. It's all web-based. Now, we also have the social part to it at CloudxLab. There's a discussion forum where lots of people keep discussing things. And then there are comments. Every topic, smallest topic has comment section below it. So you will see that lots of people are writing comments on various pages. And there's a user profile where you basically can follow and message each other, as well as you can display your XP points are displayed on your profile. Okay. There is a dedicated jobs portal. We'll be posting more jobs. We basically, instead of actively posting here, we usually email to our user base, those who have signed up with CloudxLab. And we also conduct something called exams. Okay. So what we usually do is, right, recently, we conducted something called placement eligibility test, where more than 5,000 people appeared for the test. And once they clear the test, once they get good score, we connect them to the industry. We have around 20 companies lined up to taking the candidates from us. And not to mention, we ourselves, CloudxLab ourselves, would be hiring close to 7 engineers from our own pool of learners. And yeah, over to you, Tarun. Is it possible for you to share your screen? I might have to step out for a moment.
Yes, so yeah, sure. You just give me a minute.
feel free to ask questions. I'll be available. And yeah, all right. Wonderful. So Professor Tharun will be taking you through the machine learning and the AI journey. And
Yeah.
Perfect. Perfect. Thank you, Professor Tharun.
Yes. Thank you again, Sandeep. Let's just move this one. Yes, and now see. So as the course rightly points out, the theme of the course is basically data science. So we will try to give or try to understand myself that what exactly data science comprises of. Just to give some pointers here. Yeah, truly speaking, data science is not just math, or data science is not just a science, or it's not just engineering. I would say data science is an interdisciplinary field. Essentially, you can see in this picture here. So essentially, if you have a pool of data around you, so each one of us is bombarded with a lot of data, raw data as noisy data, which is noisy data, and also very uh, clean data. So essentially, we need a set of scientific approaches, scientific pipelines, scientific processes, and algorithms, and also we want to build artificial systems which mimic the natural systems. Okay, so one specific reason why I was motivated to take up AI research when I was doing my PhD at IIT Kanpur was that I can understand myself, or I can understand the natural intelligence when I try to mimic it and try to model it in an artificial intelligence manner. So this is one reason which motivated me to take up data science or AI for my research. So I hope many of you are also motivated in that direction to understand who we are, or how to understand the natural intelligence. But in the process, I want to explain that data science is an interdisciplinary field which actually tries to extract these various insights and meaningful information from different kinds of data. So again, when I say data, what is data? So everyone is looking for data. Every company or every entity essentially is looking for meaningful data. So data can be broadly classified into structured and unstructured data. So structured data is which is organized. You can see in the spreadsheet, you can see tabular form, and you know specifically what each column and row stands for, and who's organized in a specific database, etc. But when you come to unstructured data, so what are the examples of unstructured data? Suppose you mine some tweets from Twitter, or you take some tweets from Instagram, you know. So these all are basically some examples of unstructured data. So how we can actually process these different kinds of data? So there's a lot of diversity in the data as well. So there's structured as well as unstructured. So how do I understand to scientifically process that data? So this is what is this field of data science. So as I try to explain here, data science is not just engineering, it's not just sciences, or it's not just math. Math is part of science, but it's not just math also. So data science is a conglomeration. Essentially, it's a combination of or intersection of all these various disciplines which you see here. Essentially, from the science side, science background, those who are in science background also can join this discipline and try to get some insights from this from the data. So we have mathematics. So mathematics includes linear algebra. Mathematics includes concepts of probability theory, concepts, various under different concepts, basic concepts. And statistics, for instance, you have statistical tests, statistical inference, and information science. You have information theory, information, Shannon information, etc. And domain knowledge, essentially, if you are working in very specific domain, say natural language processing or computer vision or biomedical domain, say cancer classification, breast cancer classification. So basically the domain knowledge also is part of data science. So, and finally, computer science is also a very essential ingredient of data science. So the data science is essentially a conglomeration of all these entities. So at the intersection of all these entities. Now comes the question, the very $1 billion question of this entire talk. What is machine learning? So how do you understand what is machine learning? So before we talk about any topic, it's very important to look at the history of the topic, essentially who has actually started this domain or this topic. So if you go back way back in the 90s, this 20th century, this last decade, essentially, I mean to the last century, essentially. So where the basic research in AI was started in the 1930s, 1940s. So Arthur Samuel was one of the very pioneer in this AI research. So he actually coined this term machine learning. So what is machine learning? So Arthur Samuel gave a definition. So essentially, there were several AI conferences in US. So at one of those conferences in those days, Arthur Samuel coined this definition. So what is machine learning according to Arthur Samuel? So Arthur Samuel says that essentially machine learning is that field of study where the computers are learning from the data without being explicitly programmed. All right. So everybody understands how a computer works, right? So you have to give certain instructions in the assembly language, and the computer, how the computer works. It has registers, it has memory, it has digital circuits, and then there are instructions in each of those entities, right? So, but actually, machine learning is to give the computers the ability to learn without being explicitly programmed by those rules. Okay. So what is meaning of this? So essentially, machine learning is actually learning from the data, just from the data points, and not from any specific rules, so which govern the learning methods. Okay. So it looks little abstract, the definition, but as we progress, this will be more clear what is rule and what is machine learning. So with every concept, actually, we need to have an example to understand that concept. So the concept of machine learning can be presented with one real world example. Here you can see. So everybody, I hope, must have played this game Mario in your childhood, I would say. Without Mario, many of us might not have even thought of, or would not have think of our childhood. So essentially, Mario is basically a character. You can see here, Italian prince. Essentially, he tries to go to the castle and save the princess from these entities which you see here. So there's a tortoise and there's these people who are actually trying to curb him from reaching the princess. So have you ever played Mario? So I have played Mario. So I can see here. I hope many of you have also played. So how much time does it take to learn and win the princess? What's the question? So you can answer this question if you have in the chat. So how much time do you take to learn and win the princess? I hope somebody answers in the chat. So the question here is, can I get to play Mario by using machine learning? Or can the Mario, or basically can computer can learn to play Mario and play itself against and win the princess? Okay. So this is the very good example of machine learning. Okay. So let us see how the program learns to play Mario. So essentially, so how does the program learn to play Mario? So what happens is essentially that the program learns to move. So essentially, as you progress in the game, the Mario character, essentially, he learns to counter these enemies properly. Okay. So initially, as it starts playing, maybe he's kicked by the enemies, or he's going to take more time to reach the princess. But as he progresses, if the program learns to play Mario, Mario would finish the game quite in a quite less duration of time. Okay. So how the game plays, the machine learning computer essentially plays the Mario is observes the game, how when somebody is playing. So it learns from that experience, and it itself will play the game and try to maximize the score. So score here is essentially the score of Mario winning the burger here, and also the time it takes, the minimal time it takes to complete the game. Right? So I hope this plays here. So you can just see this, how Mario is playing. the game using machine learning. So initially Mario is hovering around. Basically, the computer is pressing keys randomly. You can see the joystick and then how the joystick is pressing there, right? How the instructions are given by the machine learning program. Now come to the day 2, like when the machine learning program learns a bit better. So it is now it's playing, still it is looking random, but it is still able to progress better and able to at least go through the first step. And as time progresses, you see here, Mario is going, Mario is winning coins, and it is also learning to jump on top of these entities, although it's still stuck here. So this is where it is stuck again. So slowly it has to learn how to cross this adversity as well. Yeah, it has learned now. So it has now almost tried to perfect the game. So it has taken some time. Now Mario has become quite expert. So after these few weeks, so 2 chances are left here. So Mario is completely exploiting the bug and he's able to, I hope it reaches the princess now. See, on the go, it has learned how to kill these entities. So essentially you see that it is almost going to fall down and you see how it gets up. You learn to click those buttons on the joystick. So game itself, Mario itself learns it. All right. So this is a very classic example of how the game can be automated using machine learning. So I have given only one example of here, the game, Mario. So there are other games like AlphaGo. Everybody knows about AlphaGo. You know how, the master of AlphaGo was defeated by Google DeepMind program, right? So essentially, without any explicit programming, keep in mind these instructions are not manually fed, or there are no explicit rules for doing this programming. Essentially, how Mario goes and how Mario meets with the adversaries. No, so there are no specific rules. Only that it learns from demonstration. It learns by demonstration. All right, it's a very good example of learning by demonstration. All right, so far so good. So we have tried to understand what is data science, and we have tried to understand or what is the source of definition of ML or machine learning, and we have tried to understand through a real world example. Now let's try to understand what is AI. Right. So the research actually started in AI, and then machine learning, slowly has born. So what is AI is the father of machine learning, essentially the source of the machine learning. So what is AI? So as I mentioned that AI is essentially uh, to mimic artificially the natural intelligence which is inherent in humans or all living entities, right? So how do we mimic or try to understand that natural intelligence which is inherent in all the living entities, right? So what is the objective? Essentially that, so you can understand yourself better, you can understand your relationship, and essentially you can try to build useful models for the nation, for the development of the entire world. All right. So this is why AI has been, according to my understanding, the AI term has been developed, or the theory of AI has been coming up. So essentially, AI comprises of all these entities. So I would like to say that AI would comprise from the software side. You have rule-based programming, right? A part of rule-based programming, not necessarily everything. And then you have machine learning. And within machine learning, I would like to inform or, keep an eye here that essentially there is another class of approach known as deep learning. All right. So machine learning, as you understand, is about no explicit programming of computers, right? So within that machine learning, there is another kind of learning paradigm, which is known as deep learning. So what is deep learning? We're going to look at in this course. And on the hardware side, essentially, AI would also need hardware. So just like there is a software and hardware in which we are there, right? So there is a hardware and there's a software and there's a connection between them, right? There's of course the firmware or the OS essentially. So the hardware, the robots, IoT and sensors, these are also part of AI. So without hardware, it's quite not be possible, right? So essentially a conglomeration, again, I would say the intersection or conglomeration of all these entities would comprise the term or the concept of AI. So essentially, if I remember the AI research in 2009, so in 2009, a three group of researchers, Jeffrey Hinton and Yoshua Bengio and Jan LeCun, so they have come up with some development. So they have come up with autoencoders, they have come up with restricted Boltzmann machines. So these were some of the very, very basic developments in deep learning, right? So what after that, there has been a drastic development in the field of AI, starting from autoencoders to then, restricted Boltzmann machines, then to your recurrent networks like, RNN, what you call LSTM, right? And before that, you have CNN, essentially convolutional neural networks. So all these have followed, these developments have followed. And in the process, there is a very crucial development which happened very recently, which is known as generative pre-trained transform, right? So starting from autoencoders to CNN to, so before autoencoders, there were feed-forward neural networks. And starting from feed-forward neural networks to autoencoders to convolutional neural networks to recurrent neural networks. And then recurrent neural networks to long short-term memory, and then to transformers. That is okay. So these are essentially the developments. And after transformer, essentially the transformer period would have one approach, which is generative retrained transformer. Okay. So that is part of deep learning, and essentially it's a part of AI, right? So based on this generative pre-trained transformer, there was a very, very crucial program which has been developed, which is known as ChatGPT, right? What is ChatGPT? I don't have to introduce this term to you because all of you are aware, and many of us also use ChatGPT for all our daily purposes and different, sometimes official purposes and personal professional purposes, right? So ChatGPT is one such AI development which has improved some aspects of our life, right? And out of GPT, essentially GPT stands for generative pre-trained transformer. So one version of GPT is ChatGPT, which is GPT-4, right? Just like when you launch a product, there are version, alpha version, beta version, and different versions, right? So like that, GPT also had certain versions. So what is running currently is GPT-4 and above, right? So what are these GPT-4 and ChatGPT? So how do they fall within this course? So we will try to give an idea of that. So GPT-4 and ChatGPT are, of course, the large language models developed by OpenAI. Okay, so OpenAI is one of the very top tech companies which actually develop these models. And these models, essentially, as I mentioned to you, they are advanced deep learning methods. So they use advanced deep learning methods, or essentially they are deep learning methods along with certain reinforcement learning. So they would like to generate human-like text based on prompts, right? So essentially, if you give any hint to these models, they would generate your information you want, essentially, right? So in these recent years, these models have actually went through a lot of transformation and brought up a lot of transformation in the various fields of academia, industry, and intersection of academia, industry, policy making, and medical domain, and metaverse. So metaverse, everyone is now moving towards metaverse, digital twin. These different kind of terms or terminology are coming up because after these LLMs have come up, right? So essentially, this is all because this has been a very significant stride in natural language processing tasks. Yeah, I would now transfer to Sandeep. Sandeep, are you there?
Yeah. Thank you, Professor Tharun. Thank you so much for taking it forward. And yeah, I will take it further from here. So far, what I understood is okay, wonderful. Thank you, Professor Tarun. And yeah, we'll be. I'll talk about the typical workflow of building an ML model, and then we will be answering your questions, which you have put in the chat, and you have put it in on YouTube. Okay. All right. Let's start. So the when we talk about, so we just now what we learned from Professor Tarun is that learning from data has become the most important thing. We have to learn from the data, learn from the experience, and experience is basically we transform it into data. Now, how do we gather this data, right? And how do a typical project work? Okay, so the typical flow is uh, in an organization, right? We gather data. The gathering data would be from, let's say, when users are visiting your website or when some amount of network traffic is there and so on. So the very common mechanism is to use um, sort of Kafka as a queue. So the Kafka, or maybe some other queue, you might use Amazon SQS, you might use other things. So we get all of that data from different sources, put it into the queue, put it into the databases. The databases, usually when you have humongous data coming from the customer and you have millions of users, using your services, you will generate a lot of data. And that data you would store in HBase, you will store in HDFS, you will store in NoSQL databases, you'll store in other databases. So you will gather data into these sources right, into these sources. Then the next frame, once you are able to store the data and it's going on, you would like to do the cleaning of this data. The data might look like a plain text, data might look like say Apache logs or web server logs where you have all the data stored in files and it's not really clean. To do that, you might want to do Hadoop MapReduce, you might want to do Apache Spark, or you might want to write various transformation using, say, Google BigQuery and so on. And there were the older systems like Informatica, which performed the data extraction, transformation, and loading. ETL stands for extraction, transformation, and loading. And afterwards, once you are done with structuring this data from unstructured to some form of structure, then you would like to do more analytics. You might want to figure out how many users came today, how much money did you make, and so on and so forth. So that kind of analytics is done using SQL, Spark SQL, or Hive, and so on. So there are quite a few systems which do that. Okay, even BigQuery from Google, and there are almost every vendor has that in place. So the basic analytics, once you like one use case, it would be that 90% of the cases you can essentially do away with the basic analytics, right? Now the next stage comes in where you have to do a little bit more detailed analytics, like how many sales are we going to make next year? What are what is the root cause analysis? Like what is the root cause? Or let me put it this way, that given all my user base, which users, uh, bucket these users, bucket my users on the website into say 4 buckets, and then you look at it, or you do the anomaly detection that there's some users who are some of the transactions are anomaly and you kind of try to detect the fraud. So then this kind of thing where you do the predictive analytics, you do anomaly detection, you do all kinds of advanced analytics. This part is essentially called, this part is the ground for machine learning algorithms. This is where You use the various kinds of scikit-learn, GraphX, TensorFlow, MLlib, and so on. So you use these. Now, once you're here, then you might want to go for a little bit more advanced. You might want to do much more optimization. You might want to apply or use deep learning, or you might want to use, say, you might want to train your own model, and then you basically you want to optimize those models. And this is what will require an understanding of the algorithms, and you might want to further fine tune the models. And then once that is done, once you're done with doing the data analysis, cleaning, building, you might want to put it in production. Like, for example, think of this whole exercise for, let's say you are working with Amazon, and at Amazon, you want to give the recommendations, right? And to generate those recommendations, what you will do is first you gather the behavior of users. Okay, let's say you've already gathered it. Then you will do a cleaning of it and frame it like a tabular structure. Then you'll start doing the basic analysis. Basic analysis is that how many of these users, right? What is the most popular product? What is the product? What products do people like after this one? So you might want to do the basic analysis. Afterwards, you would like to train the models so that you can predict who will like what. And then once you have done all of that, you've built your model, you may want to move it to production. And how do you move it to production? Usually you host it like a service, or you build your mobile app where you stitch it together. So moving to production requires your understanding of DevOps, understanding of full stack engineering. How do you build the REST APIs? How do you build a mobile app? And of course, the deployment strategies, such as how do you make your model run and run in production. So this is the typical workflow of any this is a typical workflow of any data-oriented or machine learning pipeline in an organization. Okay. And this is more realistic than it is. So you can see here in this diagram, one part is storage, one part is cleaning, and one part is prediction and deployment. So, and based on this, you will see that this part on this side, where moving to production is needed, a knowledge of full stack engineering and DevOps is needed. While building the machine learning here requires an understanding of machine learning and deep learning frameworks. This one requires an understanding of SQL and the basics of Unix and so on. And then this one requires an understanding of the large scale databases and so on. So this part is data engineering up to here, data engineering, machine learning, and then full stack engineering or DevOps. Full stack engineering plus DevOps, this part. Okay. So there are various names, there are various parts to the individual name. Various names to individual parts. So basically, our focus at CloudxLab is that you understand the entire of the process instead of just being focused on one part. Of course, be good at one thing, but know the entire thing. So as part of this course, the data science, machine learning, and AI, the data science includes everything. Okay, putting it into production, getting the data, cleaning the data, doing machine learning, and even taking to production. So essentially, we will be talking about, you will get a course, a complementary course as part of this on data engineering and a complementary course on DevOps. Okay, so machine learning, okay, uh, up to here, okay. Can I scribble on this? Yeah. So you can say that up to here is data engineering. Okay. And from here to here is the machine learning. And this side is full stack engineering plus DevOps. Okay. And by the way, those who are wondering that there is only one block of this, but in reality, this part that you see here, it is your let's say 60% of the work. Okay. And out of 40%, right? Out of that 40%, this is 80%. And no, this is not 80%, this is like 90%, and this is 10%. Okay. So out of 40%, you can see that 90% is dedicated to data engineering and 10% is dedicated to machine learning. But this is very critical because this is the heart of the entire process. Okay. So in terms of the number of hours spent, this one, like everything, the full stack engineering and DevOps takes a lot of time because there are a lot of interfaces to be built and interfaces take time. The the data engineering takes like 40% of time, okay, and the ML engineering is 10%. So it's not, you cannot say this or that. Usually in an organization, this everything is needed, okay. So everything is needed, and therefore we expect that people should learn all of these parts. That's why we give most of these parts as complementary. Okay. And based on this, there's let me walk you through the careers in machine learning. There are plenty of career options in machine learning. There's machine learning engineer, data scientist, machine learning researchers. And most of these titles are fairly, kind of very vague. Okay. There is no, there is no fine, fine line. Like, for example, some of the data scientists would be just working on SQL, while some of the machine learning engineers might also be just working on SQL. Some of the machine learning engineers might be training the models, and some of the data scientists may not be training the models. Okay, so you will find this disparity between one job and another job, and but we will talk about vaguely how do these titles look like. Okay, so a machine learning engineer is, of course, every engineer, every person in the team needs to be good at communication. Okay, that's kind of the basic minimal requirement for working in a team, right? You should be, and your terminology, you should be acquainted with the terminology. When somebody says F1 score, you should know that we are not talking about Formula One, we are talking about a metrics of measurement. Okay, or somebody says precision or recall, you should know what it is. Okay, when I say communication, communication means that you should be clear about the terminology. You should know what it means by a model. You should not, like, I remember this joke in a team that somebody said that I work with models. And the other person from the team said, so you work with like supermodels, like those who are you see on the fashion TV, right? He said, no, 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 they're not that models. I work on the machine learning models. Okay, so communication is the primary um, primary thing in almost every job, whether you are going for full stack engineer and so on. Okay, and yes, even if you are from going for a super tech job, you should work on improving your communication. Now, the second part of machine learning engineering role is to be acquainted with the basic libraries to, get the work done. For example, Pandas. Pandas is a library which helps you process the structured data, say CSV file. Okay, you can load the CSV file, you can pick some columns and so on. Of course, and a machine learning engineer should also be acquainted with the SQL. You should know what's SQL and how it works. Okay, and and you should at least know how to get the SQL generated using the Chat GPT or Gemini. Okay. The third part is maths. You should know basics of maths, like algebra, statistics, calculus, etc. Just basics. You don't need to be a PhD in maths. Okay. You should basically, when somebody said gradient, you should be able to say what does it mean, what it means, and you should know like what's the physical significance of that. So as part of the course, we do spend some good time on maths. Okay. And then we talk the next part is the machine learning concepts like regression, classification, etc. So those are the the hardcore part of the machine learning. So these are the skills that are needed. Now, now we basically the process. This process usually varies from company to company, but vaguely you will find, there'll be screening test. That's a starting one. And then there will be a tech interview. There could be another tech interview. Then there will be a machine learning interview, and then there will be behavioral interview. This process that I'm talking about right now is based on the top company's interview process. Okay. So you see that during screening, the kind of interview you will questions you will see is like just a basic one. So this screening is done by somebody who is no, maybe a non-technical, say for example, HR. We used to give a set of questions to HR. They would basically ask those set of questions like how many like what is 2 to the power 10 102 sorry 1024 is how many powers of 2. Okay, say for example that just to clean the one. Sometimes we also give the when during screening we give the take home assignments or or some form of like aptitude questions or coding questions. So the screening round is just to minimize the traffic. Okay, minimize the number of people who are applying. Now, once you get like basic set of filtering done, then there could be in an interview there could be a tech interview which might involve a coding question. So even if you are going for a machine learning engineering interview, be ready to code. Okay, coding is something extremely important. Like for example, you should know how do you multiply matrices or how do you solve consecutive equations. So those kind of questions you should be ready with. And there could be another tech round which could involve coding computer science thing from, let's say, if you go to lead code, the medium difficulty kind of questions. Now, the third round would be around machine learning. So usually the machine learning based questions in these machine learning engineering interview involve involve case based scenario based question. Like you are you want to build, say, recommendation of products at Amazon. What is the process would you follow? How would it look like? Or you want to give the place recommendation at Google Places in Google Maps. How would you build it? So that will be the machine learning interview round. Sometimes there are two machine learning interview rounds instead of two tech rounds. And the other round of machine learning could involve asking the design of a particular algorithm and so on. The fourth round is generally a behavioral round, or sometimes people call it team fitness or leadership round. Okay. And essentially, these are the interviews done by the these are interviews done by the software development management, SDM we call them, or senior managers. They basically do the behavioral round. And in behavioral round, the kind of questions they will ask is that what are the most difficult thing you have done in past? Give me a couple of examples where you failed, and how would you succeed next time? And what did you do in order to mitigate the risks of failing in that project? So those kind of questions where to judge your general demeanor and behavior is one of the rounds. The most important part about the behavioral rounds everywhere is that you should be honest with what you're doing, and you should write down your story before the interview. That solves it. So I think this is a general process followed for the machine learning. And when you are getting hired for machine learning engineer role, you basically have to have an, I mean, I've already talked about these parts, so you should have the basic understanding of linear algebra, statistics, probability, and calculus. And you don't have to be like a PhD on these subjects. You are just understanding is good. Okay. You should have an understanding of pandas, NumPy, Matplotlib, and SQL. And of course, machine learning concept. You should know the various algorithms that are there for supervised learning, and you should have a clear understanding of how does a machine learning end-to-end project works. Okay, you must have the understanding of end-to-end projects. Okay, you should be able to build the end-to-end machine learning project, that you divide the data into training, test, and then you train the model on this, and then you select which model. You train multiple models, you select the best model, then you fine-tune that model, and then you basically compare its performance on the production data, and then I mean the test data, and then you put it in production. Okay, so all right, it's good to have knowledge on deep learning concepts, and it's better. You should be comfortable with things like gradient descent algorithm. Okay, now let's talk about the PG certificate program in Applied Data Science and AI by IIT Roorkee. So this course particularly is going to be 8 months overall. And yeah, there will be some part from industry, some part from the academia. The core part on the science part of it, where we talk about the algorithms and everything, that part will be done by IIT, and the engineering side or the applied side of it will be done by the industry experts. Some of the classes I'll be taking, most of the classes will be taken by Professor Tharun and the professors from IIT, other IITs, or maybe IIT Roorkee. All right. This is general overview. Tarun, do you want to add something to this?
Yeah, Sandeep, actually, yeah, I think I'm okay with whatever you have said. I
Okay,
agree with all of that. Yeah.
perfect. Perfect. All right. So yeah, that's about it. Let me take a look at the questions. Okay. All right. Let me see if there are questions. Okay. A question from Hemant is that can we consider the PG certificate as higher education? So Hemant, this is definitely higher education. Okay. Basically, there is this body called WES. Okay. WES is for World Education Ratings, or you can say World Education Equivalence Ratings. So that recognizes this certificate. You can go there and check the equivalence of the certificate. So that should help you decide upon it. Okay. Will we also learn how to create custom model in the course? Of course, the entire core of the course is to learn how to build your own custom models, and also how do you debug and fix the problems with the model. And that can only happen if you have a solid understanding of how each model works. So we'll be spending good time on that. A question from Akash is how can one train their own LLM, and how do these LLM learn answering so many questions? Okay, so LLM primarily learned how to predict next word. Okay, we trained large models which take the sentence, part of the sentence, let's say first 100 words, and then 100 first word is what it is predicting. So it learned to predict the next word, speaking the next word, and giving the previous words. That's the purpose, that's the main core heart of LLM. And then, after a while, after after a while, it people realize that it actually can talk like people just by predicting next word. So you take the next word, put it back in the question, append it to the prompt, and then it generates the next word. So it generates one word at a time, and that looks like an answer. Okay, so it's not really memorizing all questions that are there. Instead, it is studied to predict the next word. And this pair of the input and output, input is the prompt and the output is the next word. This has been generated from the data from all of the internet. So that's how it works. Okay. Okay. A question from Bhola is that will we use Bedrock and SageMaker in Gen AI use cases in this course? Yes. So there will be many questions about the different libraries. There are quite a few libraries platform that are available, but the truth is that the science is same. The science of machine learning and data engineering is same across all these platforms and frameworks and libraries. Okay, so we will focus on the science of it so that you can do machine learning on any platform that you want. Okay, as a general thumb rule of learning, you should not be learning specific skills. You should not be only learning the specific skills for a particular platform. Like, okay, I am only a AWS person, right? Or I'm only going to do this. We should always learn the skills that are generalizable. Okay, and our core focus remains on that. Today it's let's say AWS, tomorrow is GCP, and later on you might want to do it offline and so on. Okay, so we'll focus more on the substantial core of it, which you can apply anywhere else. Okay, a question from Rahul is, I already joined this program. I'm not sure if this is a apply now or it's a, this is a basic orientation, Rahul. This particular today's session is orientation, so it's not, the apply now is not really valid for you. We will be starting the course very soon. Today is just an orientation of basics of machine learning. Okay. A question from Sarika. Hi, Sandeep. Good morning. I was going through the courses for example Python. It has 134 chapters. Will all of these courses and concept be covered in live session? So see, Python and lots of it is essentially all of us are expected to learn by ourselves. But we do cover the Python in details. I mean, when I say Python, we learn about how to solve problems using Python. Okay. Our question is, how many credits hours equivalent will this course have if some students have already completed WES evaluation? Yeah. This course will have different number of credit hours equivalents. I think I can probably put it on the CloudxLab landing page, and also will answer this separately. Okay, I will note this question and probably reach out to you. Okay. In the meantime, you can just drop an email with the question to reach us at CloudxLab. My team will answer to you as well as update the website. Okay. All right. A question from Rohan is live session conducted daily? It will be on weekends. It'll be on weekends. All right. So great. All right. Any other question at this moment? Everyone? Let me see if there are questions on YouTube. Okay. All right. Okay. Most of the questions are being answered there. So, all right. Perfect. Perfect. Okay. Let me walk through frequently asked questions. Which one question that keeps coming up is, which programming language should I learn? My answer to that is does not matter as long as you are able to build or use ML concept in that language. You are all okay. But people these days prefer to use Python. So if you are starting to learn a programming language, go with Python. Okay. Do I need to be good with maths? You should be good with basic maths. And you should be good with basics of probability, calculus, statistics, though we have a refresher course in this. I'm a student from a non-CS stream. Can I also plan my career in machine learning? Of course. Most of the people are in computer science and machine learning. Most of the people are interdisciplinary. And you just have to be comfortable with the computers. I mean, the programming specifically and maths. Okay. The basics of maths. Yeah. What is the scope of machine learning engineering? Is it hyperfuture? Every usual task is being automated, and this is even increasing. This will even increase with the time. So as of today, what I see is that machine learning engineering, ML engineering is the real job. Okay. It has come from industry. As of today, if I have to hire, I would prefer to hire an engineer as well as a data scientist together. And that's what people call a machine learning engineer, right? The difficulty in having very expert data scientists but not a good engineer. They don't know, let's say, how to do the engineering. And you have like engineers who don't know the machine learning. If you have these two kind of people, usually the projects do not work. We need somebody who know both sides, who are comfortable with the machine learning as well as comfortable with engineering. Okay. How important is data structures and algorithm to crack machine learning engineering interviews? So the deep understanding of DSA is not required. However, if there is a requirement, someone who can develop software and implement machine learning, then right, DSA questions would be asked. So, like for example, in some of the jobs, they might ask like basic coding questions, like print all the permutations of this, or you might be asked simple questions about, let's say, how would you do the dot products? Okay, so those you might think that those are algorithm questions, but these are simple coding problems. Okay, so basics of algorithms, and data structures you should be comfortable with, but not too advanced. You don't require that much. Okay, so that's pretty much about the discussion today. Okay. Yeah, a question from Hemant is, how will we get the certificate? Any final exam? So basically, for this course, the most mandatory thing is at the end of the course, you must um, you must present your project. So everybody has to do one large machine learning project in which you will take a problem, take a data set, do the predictions on it or do the machine learning on it, you know, come up with the problem statement that you want to solve and solve it using machine learning. And then you have to present the same in IIT Roorkee to the professors. You have to go to the campus and you have to present your project to the professors as well as CloudxLab mentors. Okay, and this will be an unsolved project in the sense that CloudxLab or somebody will not be helping you in this. We will be helping only if you are stuck, and there is a it's kind of you are not clear about what you're doing. Okay, but this is not this is something that you have to do and you have to present. So that's the mandatory criteria for getting the certificate. Okay, if you are not confident about presenting it, if you're not confident about doing this, you won't be able to, yeah, get the certificate if you're not going to present. All right, so that's a primary mandatory criteria. Also, those who are looking for the statement of marks, they have to basically appear for test by the IIT Roorkee. IIT Roorkee has its own test, and they would be conducting that test. And based on the test, you will get your scores. It's up to you whether you want to show that scores to somebody or not. Okay. A question from Sam: how will AI impact the programming career? Will AI replace most of the roles? What is the future career path for those with CS degrees? CS degrees are going to be much more important. Okay. Or you can say that I'm not sure about the CS degree, but I'm very clear that programming roles will remain. I would believe that the coding things would probably become part of high school, and that application of coding will be part of everything. So I believe that most of the roles will have mandatory machine learning and data science course going forward. Okay, and yes, programming career is going to stay no matter how much we say that the AI is writing code, but right, AI, computers writing code is not new. It has been there for very long. Just like calculators were invented in 1950s, not 1950s, in 1900, our children mathematics, right? Because it's needed. So calculators did not replace maths. Similarly, um, AI is nothing but like autocomplete text. It's not going to replace programmers, it's going to augment them. Okay. So because programming is more like poetry, it's not being a typist. Okay. So yeah. So I hope that makes sense to you. So because coding or building anything requires a lot of problem solving, a lot of understanding of subject. The AI is not yet there. Okay. Even if it becomes there and it is there, the most of it will be used by programmers themselves. Okay. Now, question is, does data scientists need to learn DSA, or data science is good enough for them? Basics of DSA you should know. Okay, basics of DSA you should know, because like when I see most of the interviews, I expect every data scientist to code. Okay, and coding larger problems is what we call it, the data structures and algorithms. Okay, is this uh, is this program for BCom students? We have 3 years of which have 3 years of maths. Uh, I would say that your BCom degree should not stop you from attending this course. Okay. And since we start everything from basics, you should be able to handle this course. Okay. A question from Nikita. I was wondering if someone with no programming or coding background would still be able to go through the program. The beginning, first couple of months, we are going to spend good time on coding, and you should be ready to learn coding. Okay. So I would say that consider this as a wake-up call, and consider it as your learning first step into programming. Okay, so first couple of months we're going to spend in coding. Okay, how to write in like how to solve problems using code. So consider it the course to be your first stepping stone to coding. All right, and then we will start with machine learning. Okay, all right. Thank you, everyone. And any other questions at this moment? A question from Rahul is, can we move faster than the course? Of course, of course. I'll just give you an idea, like, what does it mean? It's a good question. So let me just walk you through something very important. Okay, something, okay. You can see my screen. So if you go to CloudxLab, okay, and those who have already taken my course, they will see my courses. Okay, if you take a look at any of these courses, say I'm going to show you the other course, say PG certificate in this one. So you will see that the course starts somewhere. This is like the course overview. Then there is a lab overview, like how does the lab at CloudxLab works. If you want to understand what is where, you can do that. And then getting started with various tools. So this basically gives you the overall picture of what is where in CloudxLab, if you are inclined to. Okay, this is optional. This is optional. This is also optional. This one is right. This one is a session recordings for the PG batch. So we basically record every session. You can see that these are all of the sessions that are there. So we basically record all of these sessions that are happening and keep on making it available as part of the course. Now, the other resources, additional resources, we keep on adding into the course. Okay. Then we basically have Linux basics. Okay. The Linux basics is something that we expect everybody to go through, whether you are doing DevOps, full stack engineering, machine learning engineering, data scientists, or on the cloud or on your local machine. Understanding of Linux helps you a lot. Okay. Or the other way, if you are not aware of Linux, that stops you, or that becomes a big hurdle in your progression. That's why we have kept Linux the first thing. Then a common thing is to manage the source code. So we expect that you should learn about how to manage your source code, and whether you're a program manager, writer, or a lawyer, an understanding of Git always helps you. That's why we have kept two tutorials of Git. One is a basic one, other is hands-on assessment. The topic number 9 is where Python starts. So we have the chapters on Python. You should finish all of these chapters and then move ahead. Then we have the project for churning email inboxes with Python. So essentially here what you see is what you see is basically the full project on Python that you should go through. And in addition to this, we are adding more projects to Python. Some of the projects are related to AI. Okay. Now we have like a SQL tutorial, and then NumPy, Pandas, Matplotlib, and everything else in this. And there are quite a few projects, those who are interested more. Okay. So, and lots of optional projects. So those who want to progress, and we do not restrict you, from, moving forward. Okay. So yes, the simple answer is, of course, we allow, or we actually celebrate people moving faster than the course. Okay. All right. So this is what's going to be, and the course is going to be started very soon, in a week or so. And if you get stuck at any point of time, yeah, I forgot to show you that part. Okay, let me just show you. Okay, say you are here. Okay, so if you get stuck at any point of time, if you go, let's say you're working with NumPy or let me just take an example of Python. Let's say you are at this particular chapter. Okay, and okay, on the right-hand side, you will see let me log in. I've been logged out from this. Okay, I'll have to refresh once. Yeah, good. So basically, let's say we are here, and we are stuck at this page. Okay, usually you can just scroll down and go through the comments. Lots of people keep on, you know, mm, asking questions and answering it, and this is quite useful for everyone. So you can also just put a question here. Somebody from the tech team or right CloudxLab team or other student will reply here. Okay, so if you get stuck at any point of time, just ask a question then and there. My team would answer, or right, we would have like a WhatsApp group for you, and you just ask in the WhatsApp group, or just drop an email to reach us at CloudxLab. Okay, so that's how you become unstuck. If you have real like some doubts, you can schedule a one-on-one with the mentors, and that could help you. All right. All right. I hope I answered all your questions.